panel here to tell us a little bit more about AI and polar frontiers. So innovations in the icy landscape, which is, I think, what it's been in London this weekend. I must say, it's been very icy. The panel will explore the transformative role of AI in understanding and navigating polar ice environment. Our chair is Sophie Arana, who is a Research Application Manager at the ATI. Over to you, Sophie.
Wonderful, thank you, and hello everyone. First, I'll start by introducing our brilliant panelists that we have here today. So James Byrne from the British Antarctic Survey, we have Louisa Van Zeeland from the Alan Turing Institute, and we have Edward Steele from the Met Office. So let's welcome our panelists to the stage. So AI and polar frontiers is our topic. Polar regions have, of course, always been these extreme and largely inaccessible environments, which is why we think of them as frontier regions. And they're also extreme in the sense that they're changing off faster than the rest of the world at the moment due to global warming. But what's also changing is the way we as humans interact with those environments. So the way we observe them, the way we operate within those environments. So they're no longer only geographical frontiers, but also technological frontiers. And at this point in time, we have unprecedented access to tons of remote sensing data, also for the polar regions. So feels like polar orbiting satellites are being launched every year now. So there's a lot more data coming and a lot of investment being put into sensor networks being built out in that space to operate specifically in those harsh and ice-covered regions and fill some of the data gaps that we have up to date. And it just seems like it's a very exciting field to be in as an AI researcher. That's where you want to be, where all the data is. So I'm very excited to dive into some of these topics. And we're going to talk about some of the current AI solutions that exist based on the work of our great panelists here. And we're also, importantly, going to dive into some of the challenges in bringing those AI innovation into real-world solutions. So kind of carrying forward some of the themes that have been raised in previous panels as well. Brilliant. So I'd like us to start by just giving you each a chance to introduce yourself. And we've kind of put the panel together to really have complementary viewpoints in that kind of pathway from AI innovation to operation. So if you could each just say a brief word around what do you work on, and how does AI fit into it, and what's your role in that life cycle? Ed, do you want to start us off, please?
Thanks very much. Hi, everyone. It's a pleasure to be here. My name's Ed Steele. I'm IT Fellow for Data Science at the Met Office, which broadly means my role is about championing the use of machine learning and artificial intelligence across the organization. My core interest is in decision intelligence and helping people make better decisions earlier. And my focus for the last 5.5 years or so has been leading the Marine Applications team, where we've been helping to de-risk multi-million-pound operations for the offshore energy sector, helping support the safety of life at sea, and importantly also evolving sector-wide standards and ambitions for how these data can be used in a real-world capacity.
Hi everyone, my name is Louisa Van Zeeland, and I'm the new research lead for the multimodal CIS forecasting project at the Alan Turing Institute. My background is in signal processing in engineering and also computer science, so I guess I use AI pretty much every day in my work. We are looking, the last few years, my focus has been on marine conservation, AI for good, and also on polar environments and studying how CI is affecting our polar ecosystems.
Hello, I'm James Byrne. I'm lead research software engineer for the digital innovation team in the British Antarctic Survey. So my group there focuses on working with all of our digital groups within the organisation to produce digital solutions that incorporate new technologies, including, of course, AI. Specifically, I've worked for many years now on IceNet, which was developed in partnership with the Turing Institute. And we've looked at ways of creating a pathway to impact using that technology.
Brilliant. So most people here in the room won't necessarily have first-hand experience of polar environments, but James, you've been to the Antarctica multiple times.
Yes.
So could you maybe kick us off by painting a bit of a picture of what these environments are like and what are the challenges?
Yeah, so I was lucky enough to winter at one of our research bases, Rothera, which is on the peninsula, and I spent many seasons at Halley, which is a floating base on an ice shelf that has meandered its way on top of the sea. So during my time there, I was an operational data manager, and basically the trick is how do you get data back from a very hostile environment. The bases have relatively good telecommunications. We can run instruments there like radars or glaciological instruments, or at Rothera there's a lot more on the biosciences side of things. But of course they're just 2 points, and we don't have many bases in Antarctica. What we do have are networks of instruments further afield. So this is where the challenge comes from operating in Antarctica, is that you have lots of deep field instrumentation, not lots, but enough to sort of plug some gaps. And getting data back from those sites is both environmentally costly in the amount of fuel that you have to use to get out there. Everything comes with a cost when you do it in Antarctica. But also it's just challenging to maintain these instruments. It's challenging to deploy new instruments. And things like that. It's a lot of fun working down there, but as I say, it's not something, you don't have mobile networks in Antarctica. Everything's done via satellite or done by going out and getting an SD card out of an instrument that has just overwintered in -50 conditions with blowing snow all year round. So that data becomes extremely valuable, and I think where it's a challenge for us in Antarctica, it's a challenge also in any other terrestrial or marine environment where there's very sparse data points. So that's really the fundamental challenge of working in Antarctica. Living in Antarctica is a slightly different matter. It's a bit of a challenge to do that, but that's probably a different panel, to be honest.
Brilliant. And so you mentioned kind of different extreme environments, also like marine environments. So maybe Ed, you can kind of complement from your work with the marine sector. What do the challenges look like there?
Yeah, I think the Arctic environment's a really good example of an extreme environment, but any offshore environment is similarly remote and similarly hazardous. And so keeping people safe in those environments while also trying to do useful work has a unique set of challenges which are very different to some of the factors that, as James says, we take for granted when working on land. It's inherently a 3D environment, so we're not just worried about a planar surface, but we've got waves, we've got currents that compound some of those remote challenges, which bring with it additional requirements regarding logistics and complexity associated with that as well.
Yes, and then I guess that leads us to the question, how does AI help? That all seems like very real, kind of hands-on problems, right? And now we have some AI models. How do they fit in? So, yeah?
Well, so on the use of AI is to make value of that data. So where we're talking about the real, like you say, the real world acquisition of the data, how do you then extract the value from data, and how do you plan what you're then going to do in order to infill gaps in that data? So it's the big cycle of, for BAS certainly, some of the things that we do are looking at how do we improve our operations so that they're less carbon costly, so that they're filling in data gaps. AI is at use in both of those situations, but also we partner with organisations, the Turing, but also conservation partners and others, in order to say, well, what's the real world application of these data if we collect them? And yeah, we could go on a little bit about the various ways, as we probably will.
Yeah, we'll dive into that. Maybe before we go there, Louisa, do you want to just tell us a bit more about what type of AI is really kind of being used in that space, both what your team is developing, but also in general, kind of what are the state-of-the-art models that are being applied to this data?
Well, I'm going to be a little biased. I think IceNet right now is state-of-the-art for sea ice forecasting. So IceNet, you know IceNet way more than I do. I've been working on it for so many years. It does like a 95% accuracy, I believe, for 2 months out predictions. So my team right now is trying to kind of working along with IceNet. We're using IceNet, the toolbox that you have been building, to kind of build on top of it, looking at the multimodal, multi-perspective of the data. So we have a lot of reanalysis data, a lot of open source data, but there's a lot of bespoke kind of data set that's been collected that, like you're saying, like data gaps that you're trying to fill in, that is not that easily implemented in the current AI. So what I'm trying to do, what my team is trying to do is to, okay, we're going to train a model, and then can we use all these like data set, the raw observations, and make it more bespoke for the people who are using the data to be more operational.
Mm-hmm. And what are the kind of architectures in terms of AI models that you will apply?
That's interesting. So we are looking at multimodal. So we are looking at multi-data sources instead of doing feature engineering. So I don't know if you remember back in like 2000 to maybe like 2015, even now perhaps, we want to do feature engineering. So we want to create nice features for the AI model to learn from. And then there's this like deep learning came out, and they were like, well, let's just throw data into the network and it will learn. And coming into the forecasting world, I noticed that we are kind of going back to feature engineering again. So I think that's where the difference is for me. So in IceNet, we have 3 data sets combined together into a unit source, into the model. So what I want to do to kind of lead this project is to like look at all these data sources. How do we find a probabilistic way to combine them, going through multiple AI models that choose the best way forward, and then combine them. So intrinsically, it's actually doing an ensemble of models, but not triggering the initializations to get different pathway, but actually having like multiple pathway going through different models, combine them in an intelligent way to get uncertainty quantifications.
Mm-hmm.
I think just building on what Louisa said, I think we hear a lot about the opportunities of AI in terms of cost, in terms of efficiency, particularly in terms of speed. But I think actually it's that component there that's a really undervalued aspect in terms of bringing together multiple data sources to be able to improve decisions. Because actually, certainly from an industry perspective, then having that resilience and the robustness of that is really, really critical to be able to account for dropouts and account for different data types. And so that multimodal capability, I think, is, and the opportunities associated with that for harmonizing different information and standardizing that actually makes decision-making downstream much more efficient because you've got a single point for interfacing with that as well.
That's very interesting. And from your kind of experience with working with end users of these systems, what are the data sets that you think in the marine space are kind of most valuable to combine?
Well, I think the value, as with a lot of these things, really stems from the understanding of the specific operations that they're facing and the specific decisions that they're taking, and those vary at different stages of an operation and indeed between different operations. But it's about understanding those use cases in quite some detail with a view to trying to optimize the business performance that you can then reconcile that with the scientific opportunity to be able to support that decision making.
Yeah.
I mean, that's a really interesting point, isn't it? Because we've been doing some talking, and actually it's the chicken and egg situation. Which comes first? Is it the user need or the science need? And I think that's where, with IceNet, the research, we identified that sea ice forecasting is a really important part of our operations and other people's operations, and that led to the research. But it wasn't until the model was developed, the original IceNet was developed and was successful at beating the numerical model at the time. It wasn't until then that we could really reach out to the users and say, this is worth having a look at. Here's some uses that we can go on. Here's some model that we can give you to actually derive some intelligence from.
Yeah, James, so you've been working with the IceNet team from the very early days, and we've been mentioning it now, but maybe you can give us kind of like a bit of an idea of the journey it has gone through. You mentioned a couple of milestones already?
Yeah, sure. So the original paper was published in 2021, I believe, and the tail end of 21, and that's about when I came on board in order to collaborate with the Turing. And the basic idea there was that the research was identified as extremely beneficial. So it was centered around a UNet architecture, combining some of the data sources that Louisa mentioned. So that was atmospheric reanalysis data alongside OCSAF passive microwave sea ice data. And it combined those and trained a UNet, and then basically it demonstrated very good 90+ accuracy, 90+% accuracy at the time. I came on board in order to say, well, how do we actually get those forecasts to someone? What's the method to create a digital solution around that? I always talk about a proverbial onion, where we started wrapping that research in automated pipelines to produce a daily forecast. We also were approaching at the time not monthly resolution, but daily forecasting resolution up to 3 months in advance. We automated that, and then we started talking about APIs, and we started talking about what format do those forecasts take that people can then consume. And that's happened, the original proof of concept happened in 2022, but it's been ongoing ever since. So we've been working with conservation charities to look at the ecological uses of these forecasts, and that's been very successful. And one of my collaborators, Ellen Bowler, has a paper coming out on that subject. We've been using it for maritime routing of our research vessels, so David Attenborough. So that's an ongoing pilot that the Autonomous Marine Operations Planning team at BAS are doing. And then we're talking to lots of other people about it. So that's sort of 3 years of work, actually, just to identify what are the real-world impacts and what are the use cases for these forecasts. So it just shows that, and the research, of course, is ongoing at that time as well. So it goes back to that chicken and egg. It's just been, 4 years of taking the original research, and then I always hate the term exploiting it, but that is effectively what we're doing, is working out how to beneficially exploit it for public good.
Yeah.
I think the way that you kind of not break it, but like having the pipeline and then like putting pieces of it that we can reuse to different applications, I think that's really important, because that really benefit us instead of starting from scratch. We can actually okay, here's this environmental forecasting toolbox, and we can just call these functions and then put in our own models in there without having to rewrite the whole thing and make sure that it fits in the model we have in mind. And now it's just more or less universal.
Yeah, and I think that comes from the sort of research software engineering mindset, is how do we make these things sustainable? So when we talk about sustainability, it's not just about the carbon impact of operations, but if we're designing a piece of software, how long is that software going to be used for? And the best way of using it is to extract it and create a tool around it. But again, you're not going to do that from the outset for everything that you build, because if you do that, then you'll never actually build something of use.
Yeah, it's very interesting. It's you can see how there's this element of reproducibility for the science, but going the step further to actually also share some of the software components around it and make them usable. There's something that struck me, James. You were talking about the 90% accuracy, and actually, and then you laid out that so the initial kind of goal of measure of success from the research perspective, and then laying out the goal of now it's all about deployment. So I'm interested in that gap, right, between what do researchers kind of optimize for when they start training and developing these models, and what do the end users kind of look for. And I'm curious what you think, kind of how close are these two perspectives?
Well, I think one of the benefits to the original research was that Tom Anderson, who wrote the original paper, he focused on what is the current best numerical model that we have at this time. So he didn't necessarily he did talk to people with potential use cases for the forecast, but he also then sort of said, well, what do they already have available to them? And I think that was a really good way of approaching it, because ultimately it meant that the paper had some contextual setting for this is what we're trying to overcome with the research, but it also then effectively scope limits the amount of distance that he as a researcher had to travel in order to justify the research that he was doing, which is quite helpful.
Yeah.
after that, all of this stuff around what format do the forecasts take, who's going to use them, you can then elaborate on that. But, in order to get some research out there and say to people, this thing is available, you don't necessarily want an AI researcher immediately sort of tackling the world's problems in one go. So he looked at what was there and he improved upon it, and that was enough to feed 3 years of work. And there are now several strands of research, your multimodal work. We have other researchers looking at generative methods, as well as some diffusion methods. These strains of research are just trying to improve on what Tom already did, and they're doing that with those real-world use cases in mind as well.
So, Ed, how much does accuracy matter for the Met Office?
Well,
to put it very simply.
Probably uncontroversially, accuracy is very important. I think probably what is particularly interesting, though, in this space is the continuum that exists between skill and value. And so from a model development perspective, we often think about skill and standard skill scores, RMSE, Brier skill score, and the like. But actually what matters to the user is the value. So can they derive some useful benefit from it? And those two are not actually necessarily the same, albeit obviously a contributing component to that. So I would argue that you do need to measure both. So you need to measure not only its absolute performance, but you also need to be able to measure the benefit that that's providing. And if we're talking about overall goal, then we're really talking about, are we improving decisions for the user that they're having to make or not? And if we're not, then we've got more work to do earlier in that chain. And so I think it's a consideration of that entire value chain. It comes back to something James said earlier about the sort of scientific chicken and egg of capability-led development versus user-led development. And the reality is you need to have a combination of both. But I think to be truly successful, and particularly with that path towards implementation in an efficient manner, it's not just about focusing on the capability, but you have to have some awareness of what the user requirements are. And similarly, you have to have some awareness of the science, if you're coming at it from a user perspective, to effectively marry what those challenges and pain points that customer base is facing with what is scientifically possible or realistic to be able to achieve in the course of the project. So I think it's a combination of both.
Yeah. And Louisa, I know you're very interested in building tools that will be applied at some point. So where do you see yourself on that spectrum of building towards capabilities or building very user research-led?
It's actually quite interesting listening to Matt's office and Bas talking about it. So Turing is an AI and Data Science Institute. And we want to partner with people like Matt's office and Bas to make sure that our research is actually getting applied. And that's why we have Sophie, research application managers, to talk to people about what do they need, what are we looking for that will actually give value to our users. And then from there, we take the points that you have created and say, okay, how can we build those models that will fulfill and that give you the outputs that you need to, say, navigate SDA?
Yeah, I think I definitely agree with that perspective of like really scoping out the problem that could be solved. I think it's so important, and it's often a lot easier said than being done. So I'm wondering, do you have a lot of experience working very closely with clients and users? What's kind of the secret to releasing like a proper service, and how can it be done right, and how maybe can it be done wrong too?
Yeah, so I think from my perspective, and certainly having worked fairly extensively on data science, decision intelligence implementations across industry, academia, and government, I think for me it really comes down to understanding the detail of the challenge that the user is facing. So as well as being a science nerd, you also have to be a bit of a business nerd to be able to analyse their processes and understand what those opportunities are for improvement, and where and how those science or technological solutions can help target that. And I think this is probably an aspect of research that's often quite underappreciated to some extent is the extent of the conversation that has to happen with users. I think it's very attractive for us as scientists to think, well, we're going to dive straight into the code and we're going to produce something great, we'll build it and they'll come. But actually, as well as us developing the capability, those conversations and that early engagement with users is also bringing them on the journey towards adoption that's really, really necessary as part of that. And it's that understanding of how their processes work that enable you to most effectively target how the solution's going to be deployed. Because as we know, processes, and as I say, having worked fairly extensively across government processes, those can be quite slow to evolve. And so actually, if we're able to more effectively understand those from the user perspective and tailor our solutions accordingly, then actually you have a much more streamlined way to implementing the science in a much more collaborative manner and demonstrating that value in application, which in turn leverages further opportunities for development.
I just want to add on real quick. I love the way they say early adoptions for the users. Because if we know that, then we can actually tailor to our findings and our research into making sure that along the way we're actually working toward it, rather than just okay, I'm going to build this amazing model, giant model that's been training for a month, and then here, try it.
Yeah, and I think that comes down to the sort of basis of the scientific method, really, just applied to kind of user engagement, where we're just testing hypothesis, where we think we've got an idea for something that could improve things. How could we develop a minimum viable product, have an effective engagement with our stakeholder or with our user or with our customer, to be able to, for them to understand that potential and to be able to iteratively build on that. I think you mentioned something earlier around kind of what success looks like or what are some of the pitfalls in some of that. I think for me, a really good working relationship with a stakeholder who's really engaged is critical. I think the flip side of that sometimes can be tempting, and you see this sometimes in research proposals, where people try and engage such a broad user community that actually you lose some of that detail and some of that insight. So I see sometimes presentations, and I jokingly refer to it as a bit like NASCAR, where they've got so many logos and patches on the presentations of their slide decks of all the people that they've spoken to. But the question that then often opens up for me is, well, what is the actual quality rather than just the quantity of those engagements? And I think if you're adopting a scan pilot scale approach, which is advocated within the government's latest AI Opportunities Action Plan, then it's working with users who are properly engaged to really be able to understand that opportunity, for those to be able to be effective discovery pathfinders and early adopters, as you say, that you can then effectively adopt and scale.
Yeah, and I really liked your metaphor from earlier that user research is also just, the user feedback is also just data. And so I guess it's like making sure the data quality that comes in is the right level.
I was going to say, following on from what Ed just said, the other advantage as well, and going back to the icy landscape and the marine environment, is that usually the quality of those collaborations, if you focus in on specific routes to impact, are high value. You know, if you can save a few 100 tons of fuel an hour or a day by operating a vessel, or if you can, if you can do transformative work in an ecological space or anything like that, you know, in Antarctica, in the Arctic, in all of these environments that are very sensitive to humans, the impact story is very weighty, and it's a route to longevity, much more a route to longevity for your project, because ultimately you're going to be able to point to this thing and say, look what we did, give us more money.
Brilliant. Before we go to the audience questions, actually, that was a nice transition. If you were to be given a lot of money now, like what would be the next steps? How are your projects going to develop? I'll just want to give each of you a brief moment to kind of talk about future plans.
I could probably start off there. I mean, Louisa mentioned, you know, we've started pulling out functionality that can be used, reused more. And actually, this is something we try to do in the digital innovation team, is work out what does the future of digital infrastructure within BAS, because we are a small organisation dedicated to polar research, what does the future of our digital infrastructure look like, and the tools and our collaborations with people like the Turing and the Met Office? How will that look digitally in the future? So if I was to be given a few million quid, not personally, like as an organisation, I would probably say, well, can we develop that strategy? Can we make the future digital infrastructure a reality now, rather than hoping it emerges from sort of business as usual activities in research?
Louisa?
I think I would set up an office in Antarctica. It sounded amazing to be working on a ship in Antarctica. Excuse me. But in terms of science, I think I would want to kind of like building on what you said about making it usable, like for pieces of it. We want to continue building on that, have a really strong software pipeline so that we can kind of like using different kind of models, whatever models we want to study the environment. There's a lot of opportunities in the marine environment and also in the polar, where we are not really using all those data that's available to us. Yes, there are data gaps, and people are actually collecting them to find the data to fill in the data gaps. But I remember like I was working with a group of bioacousticians for the marine space, and they were all so excited because they want to use the sound data, acoustic data, but yet when someone from NOAA introduced and said, hey, look, we can take pictures. So now all of a sudden they were just like, oh my God, we don't have to figure out what sound this is, if it's a known or a noise, but rather we can actually look at a picture and verify, yes, this is a new species, or no, this is maybe just background noise that we don't care about. And I want to bring all that sensor modalities into our models and using because all the models are they're good at different things. So I don't want to just say, okay, I'm going to use UNet, and I'm going to use LSTM with convolutional network, and or transformer as the single mode modality, single modal, but rather just have at it. I think someone kind of mentioned it to me that kind of stuck in my head. Is like, what if we're telling the AI the wrong thing? What if we're telling it to look at it from a human perspective? But let's just let AI discover something new for us that we may not, we're not be seeing. I think that's quite interesting too.
Yeah, very futuristic. And we will have another panel on the ethics behind all of this and handing over research questions to AI too. Just kidding. There you go, Ed.
I think for me it probably comes down to James's least favourite word in terms of exploitation. I think there are some fantastic developments that are taking place in terms of the modelling that's undertaken, including work at the Met Office in collaboration with Turing on developments such as FastNet, for example, and developing these true data-driven models. I think, though, for me, on a more personal basis, there's real opportunity for bringing decisions closer to the data in some of these cases. So work that I'm particularly involved with and particularly passionate about taking forward, I've done a lot of work in terms of developing very lightweight machine learning solutions that are able to operate with incredibly sparse observations in an end-to-end fashion, including in data-denied environments, which is helpful for a number of our use cases. But also exploring other opportunities for really exploiting some of the additional technologies that we can use to reconcile this skill-value continuum. For example, be that implementation of specific loss functions, which are geared towards more value-based metrics than traditional skill-based metrics, or particularly exploiting some of the potential of large language models to effectively combine that user context with the data sets that some of these machine learning models are generating to be able to really leverage those in true context. Because as we know, the more specific you can be about a particular application, the more accurate and the more useful and usable and ultimately used your product is. So also bringing in some of the natural language processing to augment some of these great developments that are already taking place, I think would be fun.
Right, exciting plans on the horizon. We now have 10 minutes for audience questions. So please feel free to raise your hand. We already have a couple of questions online. Is there any questions in the room? Immediate responses. All right, I'll give you some more time to think of some. We do have a couple of questions online, so I'll start with an online one then. I think a really nice one to start on is this one on kind of public access of the work. So what avenues exist for the public in your AI work to focus on the polar landscapes? For example, open sourcing tools, data sets, or just the research work that supports monitoring and conservation.
So in terms of the tooling, all of this is in open source already. So you can go and find the original research weights, the models that were used for the paper online, but also all of the IceNet code is available via IceNet.ai. And then the wider tooling is, we've been talking about, the environmental forecasting tooling is all available on GitHub as well. In terms of how that progresses into the future, then we all have open source policies where that allow us just to put that work into the public domain. In terms of data, NERC, the Natural Environment Research Council, who British Antarctic Survey are part of, has a series of data centres, roughly aligned to the different centres that sit under the NERC, and all of those publish our data. When it comes to specific conservation data, ecological data, things like this, it does depend on the policy of the organisations that you might be collaborating with. But yeah, nearly any published work that you see will have data availability statements at the bottom, of course. But a lot of the tooling you'll find is open source, and you can go and have a look at it. It's probably worth shouting out as well. There's a lot of good initiatives around that describe how to use the tooling once you have hold of it, because this is kind of the annoying thing where you go along and you go to a GitHub repo and then it's just it's a lot of research code. So there's things like the EDS book that was created by the Turing Institute that exemplifies how to use the IceNet tooling in order to produce your first sea ice forecast, and that of course gives you a bit of context about how then to go around using the tooling. Because things are so constantly under development, that's all, many of these things are a work in progress, but a lot of it is well established. So.
Louisa, do you also want to?
We are very similar to BAS. Everything we do is open source. We aim to be open sourcing all our work as we move along. Data sources, why we are working with open data. So I think you said NERC, you guys storing data, but we're just using them. In terms of later on, if we have raw observations, that's a little trickier questions, because sometimes for environment, or especially working with endangered species, it's sensitive. So we will have to work with partners to determine how to best handle those data. Mm. But the trained model and all that would be based on open source data sets, and tools will be on GitHub.
All right. Any questions in the room at this point?
Thank you.
There's a mic coming your way.
Thank you. Well, I have a question about what Louisa talked. I remember back in the day, we had like feature engineering, and we used like the classic method, and it was quite difficult to like convince other people that we can use deep learning and just use the feature from there. But now I see again, when we work with industry, they want to know how they can validate, and they usually want to see what is the process of using these data. I want to know from different perspectives, both researcher and metaphys people, how should it work, which one is important, and how we should navigate using the feature engineering and the process they use with the AI information that we can get without using like the expert data.
Should I go
Yes,
first?
do you want to start?
So on feature engineering, yes, back in the days, when we process certain data and how to combine them, we document everything so that it's reproducible. And then when we're looking into just not throwing data in there, but we still process all the, say, satellite imageries, and want to make sure that the data is pre-processed in good shape before we combine them. That step is a little harder to, say, reproduce. I mean, you can set like random seed and whatnot to set the process so that you know what you're training is reproducible to a certain extent. But because we're looking at a way to probabilistically combine different data sources, internally, I think it's really important to be able to say, okay, can we reproduce that? And then start off small. Say, start with 2 or 3 data sources, not 10. And then like understand how do they interact with each other. I think that's kind of important in a way to like, okay, we're not going to create handcrafted features. We're going to let the models and loss functions to do it, but we still want to be a way to kind of track it. I don't know if that someone answered. Okay.
Yeah, but another thing is on Steele. So the interpretation, when it's just feature engineering and expert information, it's like a more trust. But when you use it in our way, like AI way, they like always ask for the interpretability and how we can understand its work the way it should work. I think it's one of the things in future that we want to use multimodal would be something to explore and see how we can do this interpretation and bring, as you mentioned, like the AI point of view, but in a way that we also can understand it. I think that's something.
Thank you. Yeah. Ed, did you also?
Yeah, I think it's a really good question, and I think assurance of some of these capabilities is really important. And actually, Turing have done some really nice work on some of the argument-based assurance. I think you've led some of that as well, around constructing those use cases of how you anticipate it being used, and then measuring against whether you're meeting those. And I think that's a really valuable step when we're thinking about developing these. I think there are really nice analogies in other sectors, such as remotely operated vehicles. They take similar approaches, and I think those opportunities are really essential for how we're taking some of this stuff forward.
Thank you.
I'll take another question online. It's actually one that came up as we were discussing about this panel. So, how do we balance using AI to help the environment whilst it uses huge amounts of energy, which could be detrimental to the ice caps? I guess we can't go without discussing that question. So,
I think it's a really
who wants to comment?
Oh no, it's a brilliant question, because it's how do you not wind yourself into a horrible realm of hypocrisy. But I think the best way that I think about, or the way that I think about it, is how do you be most responsible in the approach that you take towards developing any system. And I think this applies to AI because they're so power hungry in terms of the level of compute needed to train. But quite often, we've heard from other panels, like quite often you're training it so that the cost of inference is so much less. So if you compare it to a numerical model, that is, that's very expensive to operate on a continual basis all of the time. So can we develop AIs that are actually shortcutting those numerical methods and yielding some benefit that in the long term is saving us carbon? Now, this is a very open question. I'm a software engineer, so my approach to it is basically, can we minimize the amount of upfront costs we spend? So instead of running for the supercomputer and trying to train a model straight off the bat, can we make sure that the development process is such that we produce a pipeline, not automated necessarily, but just a software pipeline that is resilient. So when we do press the go button on doing a very big training run, we do it once. Thus shortcutting a lot of that cost. And we all have to be very conscious of this, I feel, and I do try to be.
I think another aspect to pick up on this is this is probably an area where domain expertise adds a lot of value, because ultimately a simple definition of experience is knowing when a back-of-the-envelope calculation is good enough, or when you actually need to really run the full numbers in detail. And I think, as James says, knowing what's an appropriate solution for a particular problem is really the key to being able to target the appropriate technology to the particular use case in that space. I think also something more specific to some of the Arctic environments, I think the advent of AI is obviously or the era of AI is obviously offering enormous opportunities. We're also seeing that parallel increase in terms of robotics and autonomy, and I think those two together offer really exciting opportunities for being able to redefine how we're sampling and, again, evaluating what the appropriate tools are to be able to measure what we need to in the places where we need to measure them.
Yeah, I think about it every time I run a model. Like, am I doing more harm than good being in this field and doing AI? And I think my thought, my approach would be like, we have a fundamental AI group with in Alan Turing Institute where they're focusing on lean AI. So I would love for my team to be interacting with them to find out what's a better way to, instead of training all these like deep giant models, how can we use less compute and like more smarter way, leaner way to do the same job.
Thank you so much. I think this is all we had time for. So let's give a round of applause to the panel.